Welcome to Mr. B's Auto Shop. Today we're going to be discussing a series circuit and the testing of a series circuit. In order to do this, we will need a DMM, which is a digital multimeter. In this case, it is an auto ranging one. And being this is a DC circuit, we have the meter set to DC voltage. We are going to be using this test board to help show you how a series circuit is put together, the components in a series circuit, and the testing of that circuit. First thing we need, of course, is a wire from the power source, which would be the battery in most cases, to the input of the circuit. We then pass through a fuse, a circuit protection device, which will protect for damage due to an overload of amperage. We'll then go through a switch, which allows us to control the circuit, and then from the switch to the input of the first light bulb. In a normal circuit, we would run from the ground of the light bulb to the ground of the battery, and you'll notice that the light illuminates very bright. A series circuit, however, shares the voltage, creating one path for the electricity to flow through two or more loads. So in a simple circuit, this load receives 12 volts, so the light is very bright. However, in a series circuit, the voltage is divided by the loads. So if both loads are of equal resistance, then each load will have 6 volts of energy to illuminate the light, which means the lights would be dimmer. If they are unequal in resistance, one would be brighter than the other. So the definition of a series circuit is a circuit with only one path for the electricity to flow from the battery to the ground of the battery. The circuit is called a voltage dividing circuit because it divides the voltage by the resistance of each load. And when I turn this load on, you will notice that the lights glow more dimly. I mentioned in another show about Grandma's lights, Christmas lights. You probably went over Grandma's house. She gave you a string of lights. She gave you a box of bulbs. And then you sat and replaced light bulbs. And then all of a sudden, when you replaced one, every light worked. Because in a series circuit, there is only one path for the electricity, a failure anywhere in the circuit will cause the entire circuit to stop working. So for example, if I remove this ground, you'll see it affects both lights. So you're not going to have a series circuit where one load is working. Either everything works or nothing will work. We're now going to go into testing a series circuit. So we have this series circuit. We're going to go ahead and turn the circuit on. You'll notice when we turn the circuit on, the light does not illuminate. Therefore, there is a problem somewhere in this circuit. We are going to be using the 4-step method of diagnosing the fault. So we're going to start with step 1, which is measure source or battery voltage. Our voltmeter is already set up to DC volts. It is an auto ranging voltmeter, so we will not have to select a specific range. I will place the red lead on the positive battery terminal, the black lead on the negative battery terminal, and you'll notice the meter reads over 12 volts. This is what I expected, which means I can continue to test. If the battery voltage or the power source is lower than expected, fix that first, because that could be the cause of your problem. From there, we're going to move on to our second step. And our second step is measure voltage drop across the load. If it reads 0.3 or less, we have not found the problem yet. If it reads source voltage or close to source voltage, then the problem would be in that area. So this has 2 electrical loads, so we're going to have to measure across both loads. So when we talk about measuring voltage across loads, it's every load on that leg or that branch of that circuit. So I'm going to go ahead and place my red lead in this location, and I'm going to place my black lead on the ground of the last electrical load. and you will notice the meter reads 12 volts. That means the problem is somewhere between this lead and this lead. We're then going to break down the circuit into its individual components, where in this case it would be a light bulb, a wire, and a second light bulb. So we're going to move the negative lead to the negative side of the first light and read the meter. The meter reads 0.2 millivolts. We have not found the problem yet. We are then going to measure the wire from the input of the wire to the end of the wire. If it's less than 0.3 volts, we have not found the problem. You'll notice the meter reads 12 volts. This is the problem. It has a bad wire. Wherever you have source voltage, the problem is always between the two leads. So we're going to go ahead and turn the light off, circuit off. We are going to remove the wire. We are going to replace it with another wire, and then we'll turn the circuit on. You will notice that if the circuit is good, that the voltage drop of that wire should be always less than 0.1, and in this case it's 0.010 volts or 10 millivolts. Once again, we have the same series circuit. I'm going to go ahead and try to use the circuit, and the circuit does not work. So once again, we are going to use our 4-step diagnostic method, and we're going to start with V1, source voltage. Positive goes on the positive side, negative on the negative side, and I should expect 12 volts, and that is what I have. We'll then move on to step 2. Step 2 is voltage drop of the loads. So once again, we'll place the red lead on the input to the first load, the black lead on the ground side of the last load, and we'll observe the meter. It shows 12 volts. If we read source voltage during a voltage drop test, other than measuring the source, the problem is always between the two leads, and then we'll test each component again till we find source voltage. So I'm going to go here. I have less than 0.3 volts. I'm going to move it to here. I have less than 0.3 volts. I'm going to move it to here, and I show source voltage. So the problem is between the two leads. In this case, the only thing there is the light bulb. So I'm going to go ahead and turn the circuit off, remove the light bulb, replace the light bulb with another one, and test the circuit. You will notice that the light illuminates. Now we're going to try a different scenario. We will go ahead and turn the light on. Once again, the light does not work. By now, we should be comfortable with measuring source voltage, so the first step is always going to be measuring source voltage. We're expecting 12 volts, and we have 12 volts. We have not found the problem. The next step would be to measure across all the loads. So we'll place the red lead at the power side of the first load and the black lead at the ground side of the last load. If it reads more than 0.3 volts, then we have a problem in that area. But in this case, it reads 0 volts, so we have not found the area of the problem yet. We will now move on to step 3. And step 3 is measuring voltage drop of the ground side. Ground side voltage drop should be less than 0.1. Anything more than that indicates a problem in that area. So we're going to go ahead and place our red lead on the ground side of the light bulb and our black lead at the battery terminal, and it reads 12 volts. That is more than 0.3, so the problem is between these 2 points. The only thing between those 2 points is that wire, so once again we have a faulty wire. We're going to replace the wire. Turn the light off to protect yourself. and when we turn it back on, we now have repaired the problem. All right, let us try another scenario. We're going to turn the light on. The lights do not work. There is a problem in this circuit. Step 1, measure source voltage. What voltage do we expect? 12 volts. Let's see. We have 12 volts. We have not found the issue yet. Step 2, measure across all electrical loads. So we're going to go to the input to the first load, to the ground side of the second load. If it reads less than 0.3 volts, then that part of the circuit is good so far. If it reads source voltage or close to source voltage, then we know the problem is in the loads. The meter reads 0. We have not found the problem yet. Step 3 was measuring voltage drop of the ground side. So we're going to place our red lead on the ground side outlet of the load, and we are going to place the black lead on ground of the battery. Anything less than 0.3 volts indicates the circuit is good. Anything close to source voltage indicates that's where our fault is. In this case, the meter reads 0. We have not found the fault yet. The next step is V4. V4 is measuring voltage drop on the power side. We must measure the entire power side, which goes all the way from the battery to the input of the first load. So we will place our red lead on the battery positive terminal, and we will place our black lead on the input or the power side of the first load. And you'll notice the meter reads 12 volts. This indicates the problem is between these 2 points. It could be a wire, it could be a fuse, it could be a switch, or it could be the second wire. We're now going to break the circuit down into its individual components. So the first component we will test is this wire. 0.1 or less is good. Source voltage indicates a bad wire. It is less than 0.1, so we know we have not found the problem yet. We will now go and measure across the voltage drop of the fuse. 0 would be a good fuse. 12 would indicate excessive voltage drop and having a faulty fuse. You can see that the meter reads 12, so we're going to go ahead and change the fuse. And when we turn the circuit on, you will notice that the lights illuminate, and we are showing 33 millivolts or 0.03 volts, which is below the 0.1 of a fuse. Remember, if you get to a switch and you go across the switch and it shows 12 volts, test the switch to see if it's off, because it would sure be bad if you spent money on a new switch and then you realize you didn't do that. All right, so if it reads this in both directions, 12 volts in both directions of the switch, then you would have a faulty switch. Using these 4 steps, you can diagnose any series circuit. How many loads are in the circuit is irrelevant. It just increases the number of steps you would have to do if the fault was found in the loads themselves. Once again, any failure will cause the entire circuit to stop failing. This concludes our lesson on series circuits and testing series circuits. If you follow these steps, your diagnosing of electrical problems will be very simple. This concludes the lesson on series circuits. Thank you for joining Mr. B's Auto Shop, and I will see you next time.